A golf ball travels with an initial speed of 35 meters per second at an angle of 37 degrees after being struck. Our goal is to find the horizontal and vertical components of the golf ball's velocity. Let's represent our velocity vector with an arrow. We can see that the velocity is in the first quadrant. By drawing and labeling our velocity, it makes it come to life and allows us to easily solve for the missing components. The components of a vector are the one-dimensional forces acting on the x and y axis. Here is the velocity's x component, and here is the y component. It is easy to see that the ball is moving in the positive x direction and the positive y direction. To solve for the values of these components, we will draw a vector triangle. We move the vertical component to the head of the x component and create our vector triangle. This triangle represents the vectors and creates a nice, neat right triangle that is easily solvable. It is important to note that the angle theta will always be adjacent to our x component in every vector triangle we draw. Now we can solve for our component's values. Since the x component is always adjacent to the angle, we will use cosine as our trigonometric function to solve for the missing side. We can substitute in Vx for our adjacent side and V for our hypotenuse. We rearrange the equation to solve for Vx. This will be the equation that we always use to solve for the x component of a vector. That is why it is so important to make theta adjacent to the x-axis. Next, substitute in the given data and find the x component of the velocity. In the vertical direction, we will use sine as our trig function to solve for the opposite side. We will substitute in Vy for our opposite side and V for our hypotenuse. We rearrange the equation to solve for Vy. This will be the equation that we always use to solve for the y component of a vector. Substitute in our given data and find the y component of the velocity. In this problem, we have a vector in the first quadrant. If the vector was in the second quadrant, the x component would have been negative. Here are the possible vector triangles that we can have and the signs of the components that will accompany them.